The National Electrical Code does not specifically address the height of low-voltage wiring in relation to the ground. NFPA 72, the National Fire Alarm Standard, also does not explicitly specify the height of low-voltage wiring. However, it does provide some guidance. Section 5.1.1.4 states conductors shall be supported by messenger wire, conduit, armored cable, or messenger-supported cable. Section 5.1.1.5 states conductors shall be protected from mechanical damage. While there is no specific code requirement, it is generally accepted industry practice to install low-voltage wiring at least 12 inches above the ground to protect it from damage and to ensure proper electrical insulation. To ensure compliance with industry standards and to protect the integrity of the low-voltage wiring, it is recommended to maintain a minimum height of 12 inches above the ground. This will help prevent mechanical damage, water ingress, and other potential hazards. So, let's delve into the specifics. The NEC serves as a comprehensive guide for electrical installations, yet it lacks explicit directives regarding the height of low-voltage wiring from the ground. This absence doesn't imply a lack of importance, but rather a reliance on general safety principles and other applicable standards. NFPA 72, dedicated to fire alarm systems, similarly doesn't provide a definitive height mandate. However, it emphasizes the importance of supporting and protecting conductors. This suggests that while a specific height isn't dictated, the installation must ensure the wiring is adequately supported and shielded from potential damage. Industry practice steps in to fill the gap where codes are silent. A widely accepted standard is to maintain a minimum clearance of 12 inches for low-voltage wiring above the ground. This practice is rooted in practical considerations such as minimizing the risk of physical damage from accidental contact, preventing water intrusion that could compromise insulation, and generally promoting a safer and more reliable electrical system. Recommended practices often go beyond strict code requirements to enhance safety and performance. Maintaining the 12-inch minimum height is a prime example. This seemingly small detail can significantly reduce the likelihood of common issues that plague low-voltage installations. Firstly, physical damage is a major concern. Wiring close to the ground is vulnerable to being kicked, stepped on, or struck by objects. The 12-inch clearance provides a buffer, reducing the chances of insulation being compromised or conductors being severed. Secondly, water ingress poses a threat. Ground-level areas are susceptible to puddling and moisture accumulation. By elevating the wiring, the risk of water seeping into connections or damaging insulation is minimized. Thirdly, electrical insulation is critical for safety and proper system function. When insulation is compromised, it can lead to short circuits, ground faults, and even fire hazards. The 12-inch clearance helps maintain the integrity of the insulation by reducing exposure to physical and environmental stresses. To further elaborate on the NEC, while it doesn't specify a height for low-voltage wiring in the context of ground clearance, it does contain numerous articles pertaining to the general installation and protection of conductors. For instance, Article 300 addresses wiring methods and materials, emphasizing the need for installations to be mechanically sound and electrically safe. Article 310 focuses on conductors for general wiring, providing guidelines on ampacity, insulation types, and installation requirements. These articles, although not directly addressing height, provide a framework for ensuring that all wiring, including low voltage, is installed in a manner that minimizes risk and maximizes reliability. NFPA 72, in addition to the sections already mentioned, provides further guidance on the installation and supervision of fire alarm systems. Section 10.16, for example, addresses wiring requirements for fire alarm circuits, emphasizing the need for conductors to be suitable for the application and properly identified. Section 12.4 focuses on circuit integrity, requiring that fire alarm circuits be designed to maintain their functionality even in the event of a single open or short circuit. These sections, while not specifying a height requirement, underscore the importance of reliable wiring practices in ensuring the proper operation of fire alarm systems. Industry practices, as previously mentioned, often exceed the minimum requirements of codes and standards. In the case of low-voltage wiring height, the 12-inch rule is a widely adopted benchmark. However, some installations may require even greater clearance depending on the specific environment and potential hazards. For example, in areas prone to flooding or heavy snow, a higher clearance may be necessary to prevent water or ice from coming into contact with the wiring. Similarly, in industrial settings where there is a high risk of mechanical damage, additional protection measures such as conduit or cable trays may be employed in addition to the height clearance. The recommended practice of maintaining a minimum height of 12 inches above the ground is not merely an arbitrary guideline. It is a practical and effective way to mitigate common risks associated with low-voltage wiring installations. By adhering to this practice, installers can help ensure the safety, reliability, and longevity of the electrical system. Firstly, consider the environment. In damp or wet locations, the risk of corrosion and insulation breakdown is significantly higher. Maintaining adequate clearance helps prevent moisture from wicking into the wiring and causing damage. Secondly, think about accessibility. Wiring that is easily accessible is more likely to be tampered with or accidentally damaged. The 12-inch clearance provides a degree of protection by making the wiring less vulnerable to casual contact. Thirdly, remember the importance of aesthetics. While functionality is paramount, a neat and organized wiring installation is also desirable. Maintaining consistent height clearances contributes to a professional appearance and makes it easier to identify and troubleshoot any issues that may arise. In addition to the 12-inch rule, there are other best practices that should be followed when installing low-voltage wiring. These include using appropriate connectors and terminations, properly supporting and securing the wiring, and clearly labeling all circuits. By paying attention to these details, installers can ensure that the low-voltage system is reliable, safe, and easy to maintain. The choice of wiring method is also an important consideration. Depending on the application and environment, different wiring methods may be more appropriate. For example, in underground installations, direct burial cable or conduit may be used to protect the wiring from physical damage and moisture. In exposed locations, cable trays or raceways may be used to support and protect the wiring while also providing a neat and organized appearance. The selection of the appropriate wiring method should be based on a thorough assessment of the site conditions and the specific requirements of the installation. Grounding is another critical aspect of low-voltage wiring installations. Proper grounding helps to prevent electrical shock hazards and to minimize the risk of equipment damage due to lightning strikes or other electrical disturbances. The grounding system should be designed in accordance with the NEC and other applicable standards, and it should be regularly inspected and tested to ensure its effectiveness. Overcurrent protection is also essential for protecting low-voltage wiring from damage due to excessive current flow. Overcurrent protection devices such as fuses and circuit breakers should be properly sized and installed in accordance with the NEC. These devices are designed to interrupt the flow of current in the event of a fault or overload, preventing damage to the wiring and equipment. Regular inspections and maintenance are crucial for ensuring the continued safety and reliability of low-voltage wiring installations. Inspections should be conducted to identify any signs of damage, wear, or deterioration. Maintenance activities such as tightening connections, cleaning terminals, and replacing damaged components should be performed on a regular basis to prevent problems from escalating. In summary, while the NEC and NFPA 72 do not explicitly specify a height requirement for low-voltage wiring above the ground, industry practice and recommended practices dictate a minimum clearance of 12 inches. This practice helps to prevent mechanical damage, water ingress, and other potential hazards, ensuring the safety, reliability, and longevity of the electrical system. By following these guidelines and adhering to other best practices, installers can create low-voltage wiring installations that are both safe and effective. Furthermore, consider the specific application of the low-voltage wiring. Is it for a security system, the landscape lighting system, or a communication network? The intended use can influence the choice of wiring method, the level of protection required, and the appropriate height clearance. For instance, wiring for a security system may require additional protection against tampering or vandalism, while wiring for landscape lighting may need to be rated for direct burial and exposure to the elements. It's also important to consider the long-term maintenance requirements of the low-voltage wiring system. Will the wiring be easily accessible for inspection and repairs? Are there any potential obstacles that could impede maintenance activities? By planning ahead and taking these factors into account, you can minimize the likelihood of future problems and ensure that the system remains reliable and safe over time. Training and certification are essential for individuals who install and maintain low-voltage wiring systems. Proper training ensures that technicians are knowledgeable about the applicable codes and standards, as well as the best practices for installation and maintenance. Certification provides assurance that technicians have demonstrated their competence in the field and are qualified to perform the work safely and effectively. In addition to technical skills, communication skills are also important for technicians who work with low-voltage wiring systems. Technicians need to be able to communicate effectively with customers, colleagues, and other stakeholders to ensure that the work is performed to the required standards and that any issues are resolved promptly. By investing in training and certification, and by fostering strong communication skills, you can build a team of professionals who are capable of delivering high-quality low-voltage wiring installations that meet the needs of your customers and comply with all applicable regulations. To recap, while a specific height isn't mandated by the NEC or NFPA 72, the 12-inch industry standard is a wise and practical guideline. Remember to consider the environment, accessibility, and aesthetics when planning your installation. Don't forget the importance of proper wiring methods, grounding, and overcurrent protection. Regular inspections and maintenance are key to long-term safety and reliability. Tailor your approach to the specific application and prioritize training and certification for your technicians. By following these recommendations, you can ensure a safe, efficient, and long-lasting low-voltage wiring system. And always consult with a qualified electrical professional if you have any doubts or questions. Remember that local codes and regulations may vary, so it's essential to be aware of the specific requirements in your area. Staying informed and adhering to best practices will help you create low-voltage wiring installations that are safe, reliable, and compliant with all applicable standards. That concludes our discussion on low-voltage wiring height requirements. We hope this information has been helpful and informative. Thank you for your time. Remember, safety should always be your top priority when working with electrical systems. If you're not comfortable performing the work yourself, please consult with a qualified professional. A properly installed and maintained low-voltage wiring system is essential for the safe and reliable operation of many different types of equipment and systems. By following the guidelines and recommendations outlined in this discussion, you can help ensure that your low-voltage wiring installations are safe, efficient, and long-lasting. Remember to always prioritize safety and consult with a qualified professional if you have any questions or concerns. This information is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before performing any electrical work. The recommendations and guidelines outlined in this discussion are based on industry best practices and applicable codes and standards. However, it is important to note that local codes and regulations may vary, so it is essential to be aware of the specific requirements in your area. By staying informed and adhering to best practices, you can help ensure that your low-voltage wiring installations are safe, reliable, and compliant with all applicable standards. We encourage you to share this information with others who may find it helpful. Together, we can help promote electrical safety and ensure that low-voltage wiring installations are performed to the highest standards. Thank you once again for your time and attention. We hope you found this discussion informative and helpful. Please feel free to reach out if you have any further questions or concerns. Stay safe, and remember to always prioritize electrical safety.